In this video, we're going to be taking a look at some kinematic acceleration problems. Up top in green, we have three of our main acceleration formulas, and we're going to be talking about the difference and similarities between horizontal and vertical acceleration problems. But because they're all accelerated motion, you're going to use the same set of formulas. So number one is a horizontal acceleration problem. So let's go ahead and start off with that before we move on to some vertical motion. So we have a car going at 10 meters per second. So we know the initial velocity is 10 meters per second to begin and slows down at 3 meters per second squared. Now, because it says slowing down and we're going in the positive direction, that would mean that we are subtracting a certain amount of velocity per second, which means we have a negative acceleration. And then we said, and then the end says, how far does it travel until it comes to a stop? So we know that it is coming to a stop at the end. And we want to know how far it has moved during that time. Now, anytime you're working on one of these acceleration problems, you always want to find three known variables and then find the fourth variable, which is your unknown. So we have VIA and VF, and we're looking for a delta X. So if we take a look at our three formulas, we're already down to the second and third one because this one has a delta X and this one has a delta X over here. We want to make sure we see which one we have all the variables we need. So if we take a look at this one, we have VI, we don't have T, so we can't use this one. This one over here, do we have VF, VI, and A? We do have all those three. So let's go ahead and plug those in and solve for our delta X. So we plugged in all our numbers. We have 0 squared equals 10 squared plus 2 times negative 3 times delta X. We subtracted 100 from both sides, which gave us negative 100 on the left. And then we divided that by the negative 6 in front of the delta X. And then once we divided those two, we got 16.67 meters as our delta X. So with a horizontal acceleration problem, you'll be typically given a little bit more because there are not any numbers you can assume besides if something starts from rest or comes to a stop. Other than that, you have to be given all of your values. Now, with vertical acceleration, assuming that it's in free fall, which it usually is, there are much more concepts and numbers that you're supposed to know due to the free fall due to the nature of free fall motion. So we have a rock is dropped. So the word dropped on its own tells us two things already. One, that the initial velocity is 0, and two, that the acceleration is negative 9.8 meters per second squared, as is everything in free fall motion. And it falls for 2 seconds. So we have a time of 2 seconds, and we're looking for our final velocity. So for this one, as you could see, we were only directly given one number, and then conceptually, just from the word dropped, we know that the object starts at rest at 0 and then obtains an acceleration of negative 9.8 meters per second squared because it's in free fall motion. Now let's go ahead and look at our formulas. We have one with a VF in it all the way to the right, and we have one with a VF in it all the way to the left. And if I look at the first formula, that seems to be the one we're going to use because we have A, T, and VI. So we have all the variables we're looking for except the unknown. So let's go ahead and plug that into the first formula to solve for our VF. So I plugged in all of our numbers into our formula right here. I can go ahead and cross out that 0 because it's going to be insignificant in changing our answer. And then we just multiplied both sides by 2 to get rid of that 2 in the denominator. And we got 2 times negative 9.8, which gives us negative 19.6 meters per second. That's the velocity, and it's negative because the object is moving down. Now let's go ahead and look at the last one. Again, this is a vertical acceleration problem. These ones, like I said, are typically more complicated. So if you're able to master the vertical acceleration problems, then very likely you're going to be pretty strong at the horizontal acceleration. So number 3 says a ball is tossed up and travels upwards for 4 seconds. So we have a time of 4 seconds. And if it travels up to a height of 10 meters, then what is its initial velocity? So we have a displacement, which could be delta x, in this case, actually delta y, because it's vertical, but I'll just leave it as delta x. And then they're asking for the initial velocity, and the object is in free fall motion, which means that is moving only under the influence of gravity. So we can use an acceleration of negative 9.8 meters per second squared. Okay. Also, with your vertical motion, typically you want to pay attention or draw a picture just to make sure you're sure that everything is either positive or negative. So in this one, we're looking for an initial velocity, and the 10 meters is going upward, so that's positive 10. The acceleration is always directed towards the Earth, so that is always negative 9.8, whether or not the object is moving up or down. Okay, so we have 3 formulas actually that have a VI in them. All of them have a VI. So if you take a look at the first one, I notice that I don't have a VF, so I can't use that one. And then if I take a look at the second one, I'm looking for a VI. I have T, I have A, and I have T, and delta X. So that one looks good because I have everything except my unknown. So let's go ahead and plug in those numbers into our second formula. So I plugged in all our numbers, and we got 10 equals VI times 4 plus 1/2 times negative 9.8 times 4 squared. So I took the product of all these three, and I got negative 78.4, which I added to both sides. Once I added the 78.4 to the 10, I got 88.4 meters. And then I divided it both sides by that 4 seconds to get a velocity in meters per second. So then I got 22.1 meters per second, which comes out positive because the VI is an upward velocity. So to sum things up, when you're doing a horizontal and vertical acceleration problem, you're still using the same formulas, and you still want to identify 3 known variables and find for your fourth variable, which is your unknown. And then the way you pick your formula is you make sure you have everything except the thing that you're looking for. Now, with the vertical acceleration problems, as I said before, there's a little bit more that you're going to have to know. You're going to have to know that if it's dropped, then your VI is 0. Your acceleration is always negative 9.8 meters per second squared. And also, if an object reaches its peak, its maximum height, then its velocity is 0. So you may use a VF of 0 for that. We didn't use that in numbers 2 and 3, but you may use that. So there's a little bit more conceptual type information in the vertical acceleration problems. So you're going to have to know a little bit beforehand before plugging in your numbers and then finding the right formula. Other than that, you're going to use the same strategy of labeling the 3 known variables, finding your unknown variable, plugging everything in, doing your algebra, and then solving for your final variable. So I hope that was helpful in helping you solve and understand horizontal and vertical acceleration problems. Thank you for watching.